Hello everyone, this is P. Chelapandi here. First of all, I would like to welcome you to my today's session. In this session, we are going to discuss about what do you mean by isomorphic, and followed by we are going to check whether these two graphs are isomorphic or not. So before we dive into discuss about this particular topic, let me have an example, right? So you just imagine there are two people. They are wearing different clothes, but actually their faces are same, right? So here, what do you mean by understand here? So here it means their faces are same, but they have worn different clothes, which means in structure wise they both are same inside, but in the outside they are looking different, right? So this is the concept. This concept we are going to apply to our graph. So now look at these two graphs. So when we look at these two graphs in the outside, it seems they are different, right? So but actually they are not different in the inside. If we check the inside, both graphs are same, then it is called isomorphic, right? So this is what we mean by isomorphic. For isomorphic, it should be equal. The both graphs should be equal in the inside. Okay. To check that, we have several conditions. If both graphs satisfy that conditions, then it is called isomorphic. Right? Okay. What are the conditions? The condition 1: both graphs should have same number of vertices. Condition number 2: both graphs should have same number of edges. Condition number 3: both graphs should have same number of degree, right? Condition number 4: for both graphs should satisfy adjacency concept, right? Okay. Now let me check whether these two graphs are satisfying these four conditions or not. If any two graphs are satisfying these four conditions, then it is called isomorphic. Okay, let me check. So first, what we need to find out? We need to find out whether both graphs are having same number of vertices or not. Let me check. So V1, 2, 3, 4, 5, 6. So it has, the graph 1 has 6 vertices. So number of vertices is 6 here. Let me come to graph 2. 1, 2, 3, 4, 5, 6. It also having number of vertices is 6. Right? Let me check whether both graphs are having same number of edges or not. So here, let me count the number of edges. 1, 2, 3, 4, 5, 6, 7, 8. So it has 8 edges. Let me count to graph 2. Here we have to check whether it has a number of edges is 8 or not. Okay. 1, 2, 3, 4, 5, 6, 7, 8. So the graph 2 is also having 8 edges. Right? Okay. Now, we are going to check whether both graphs are having same number of degrees or not. So, degree is nothing but, okay, number of edges which is incident to that particular vertices is called degree, right? So, here we have vertices 1, it is named as U1, right? So, number of edges means here 2 edges are incident with this vertices. So, the degree is 2, okay? Now, the degree is 2. Degree of U1, it is 2. Then let me come to U2. Here it is contributing 3 edges to this vertices. So the degree is 3. Now U3, what is the degree? 1, 2, 3. 3 edges are incident with this vertices, so it is 3. Now U4, here also we have 3. Now U5, here also we have 3. Now U6, it is 2. So this is the degree sequence of this particular graph. Let me come to graph 2. If we are having same number of degrees in this graph also, then it is satisfying 3 conditions, right? Let me check whether it is having same number of degrees or not. So here the degree of V1 is what? It is 2. The degree of V2 is what? It is 3. The degree of V3 is what? 3. V4 is what? 3. V5 is what? 3. And V6 is 2. Now let me check whether both graphs are having same number of degrees or not. So exactly both graphs are having same number of degrees. So far we have satisfied three conditions. First, the condition number one is both graphs should have number of vertices are same, and in condition number two, it should have same number of edges. Okay. In condition number three, both graphs should satisfy, which means both graphs should have same number of degree sequences, right? Okay. Now let me come to check whether it is adjacent or not. Okay. To check the adjacence or not, there are so many ways. Okay. One of the best way that I am going to take, this is the easiest way. Okay. So here you have to look at in the matrix form, you can check whether both graphs are adjacent or not. Suppose if you cannot find, okay, suppose if you feel it is difficult to check the adjacency in matrix form, you can go with some other way. I will tell that also later. Now, let me form a matrix form. So here you have to write number of vertices and number of vertices in column wise, number of vertices in row wise and column wise. So to check the adjacency, so here this is a vertex, right? Now this edge is incident with this vertex. Now we have to check the same edge, okay, is having another vertices. So this is called adjacency of these two vertices. This we have to check for all the vertex. So now V1 is contributing V2 and V3. So these two vertices are adjacent to V1, right? Understand that? So V1 is contributing to V2. Sorry, U1. So not V1. U1 is contributing to U2 and U1 is contributing to U3. So these two vertices are adjacent to U1. So you can put 1 to U2 and U3. Remaining vertices are not having the adjacent line to this particular vertices. So it is 0. Right? In this aspect, we have to find all other vertices. Now U2 is contributing to U4, U5 and U1. So these three numbers are replaced by 1. All other vertices are 0. In that aspect, you have to fill all the values. Now let me come to this graph. In the same concept, we have to fill this matrix form. Now we have to check both matrices are having same value in row wise and column wise, then it is for adjacency. Suppose if not so, then what you have to do? You have to interchange rows and columns. There, if you find both matrices are same, then you can say given graphs are satisfying adjacency concept, right? But I feel this matrix is 6 by 6 matrix, so it will take time. Okay, if you change rows and columns, okay, to match both matrices are equal, it will take time. To avoid such a situation, we have some simpler way to check whether both the graphs are adjacency or not. Well, the way is, first we need to check whether there is any cycle. Okay, if there is any cycle in between two different vertices, set of vertices. First, I am going to check in graph 1. There is a cycle U1, U2, U3, and U5 and U3. Again U1. So there is a cycle U1, U2, U5 and U3, then U3, then U1. So there is a cycle with the 4 vertices. Okay, if we have to find another, we have to find 2 cycles with the different vertices. This is the first cycle. Let me come to find another cycle with 5 vertices. 1, 2, 3, 4, 5, 6. We have another cycle U1, U2, U4, U6, U5, U3 and U1. So we have another cycle. Here we have 2 cycles with 1, 2, 3, 4, 5. With 5 vertices, we have another cycle. With 6, 1, 2, 3, 4, 5, 6, 7 vertices, we have another cycle. If we have the same cycle, same vertices in this graph also, then it is satisfying the adjacency. Let me check. So what we have to check first, whether this graph is having a cycle between 4 vertices or not. Okay. So here V2, V4 and V5, V3. right? So it is having a cycle. Then V5, one second, V2, V4, V5, V3, again this this is V4, V5, again it is V2. So this is a cycle. It is forming a cycle between four vertices. So the first condition is satisfied. Let me come to the second condition. The second condition, both graphs should have what? It should have a cycle between six vertices. So 1, 2, 3, 4, 5, 6, 7. So between 7 vertices. Here also it is forming a cycle between 7 vertices. First and last vertices are same. So that is why I am saying it is 7 vertices. So it is V1, V2, V3, V4, V6, V5, V3, and again it is V1. So both conditions are satisfying. So this given graphs are satisfying condition number 1, condition number 2, condition number 3, and condition number 4. If any two graphs are satisfying these four conditions, then that graph is called isomorphic, right? So thank you so much, dear friends. I hope you all have understood about this concept clearly. I will meet you with another problem in the next video. Thank you.